All right, so the last three here, if I'm trying to simulate going to negative infinity, I would just plug a really big negative in. So if you do 2 to the negative a million, 5 to the negative a million, that becomes 1 over 2 to the million, 5 over 1 over 5 to the million. Those essentially just disappear. So as we go left, we go right, these get really big. We go left, they essentially become nothing. So we just get that quantity of 3/4. Here, if I want the area between these two curves, I can either take this area, which would be g of x minus x, plus this area, which would be x minus g of x. That would be the answer in 3. Or I can just absolute value it, since if we are just doing x minus g of x, that would be fine here. It'd be backwards here. But so that would work if I absolute valued this. It would not work if I absolute valued the whole quantity, because the entire quantity looks to me like it would be about 0. So I would take 2 and 3, but not 1. Okay, so another separation of variables. Again, we haven't formally covered this, but we are seeing quite a few of them. So I have x, y cubed. So if I was going to solve this, I would start by dividing y cubed and multiplying by dx. So they did that in step 1, and then they integrated. So they're good there. Step 2 is where they made their mistake, because if you took the derivative of this, you'd get 1 over y cubed times 3y squared, and that's not what we want. So the antiderivative of this, it's only going to be a natural log if that's a first power down there. So they made their mistake on step 2. All right, guys, we'll catch you here for the calculator part here soon. All right.